Hello and good afternoon or good morning to the KISSsoft web demo highlights in release 2017. We are glad to present you in the following hour our newest features and highlights of the release 2017. We will share this 1 hour between KISSsoft and KISSsys. KISSsoft, this is me, Jürg Langhart from Technical Sales, and KISSsys is my colleague Cengiz Yilmaz, KISSsys Product Manager. We have uploaded also handouts for you. It means you can check in parallel our documents. You will find a complete changes document where you can see all the details. You will also find PowerPoint presentations about KISSsoft and KISSsys, and of course you're invited to download and to check these documents as well. In parallel to our session, you can give questions to us in the chat. We will in parallel try to answer. If we don't complete all to finish all questions, of course we will come back to you after the web demo. So now let's start with the newest highlights in the KISSsoft release. I will start with cylindrical gear pairs. It is a main task of KISSsoft to have the standards to a very latest state in KISSsoft, and as a sample for standards updates I will go into the tooth flank fracture calculation. The tooth flank fracture calculation for cylindrical gears. The draft, which is currently done now in the ISO committee, has been slightly reworked in the ISO committee, and therefore also in KISSsoft you will find now the newest settings which come together with the standard proposal. So it means if you go to the tab rating and into details, then you will find the two approaches now to estimate the hardness curve. It means it's now additional to the database and read from file for existing data. It's possible to have an approximation of the hardness curve according to Long and an approximation of the hardness curve according to Thomas. So then you will find, as usual, you will find the evaluation for tooth flank fracture in the graph tooth flank fracture, and you will find the graphs as usually also for the intermediate results. It means you can see hardness curve, you can see equivalent stress state, material shear strength, and then the final material exposure, which is in this case so slightly bigger than the recommended maximum exposure, which is 0.8, and in this case it means that the gear pair will fail because of tooth flank fracture. So this is just one sample for the updated standards and ratings in KISSsoft. We have many more which you will find also in the changes document. The next module what I would like to show to you is a new module which we created also in relation with the ISO committee. It is currently in discussion in the ISO committee to recalculate grinding notches again, and as a reference for that, FVM tooth root stresses should be calculated. This is the reason why in KISSsoft now also this new module is available, FVM tooth root stress, and the background is as follows. If you have a gear which has a preliminary treatment, then you will have a grinding notch as shown here. This grinding notch will increase stresses, and it's depending strongly on the details. It means in the tab Final Machining you can give settings. So let's increase now, for example, the grinding depth into tooth root, and also change a little bit the tool tip radius. Please check now the curve. When we calculate, we will find that the gear now is calculated much more to the tooth root radius. This of course influences also stresses, and now with the new module it's possible to have a rating with the FEM method. It means that we will use an FEM software which works in background. It's the same one as we have for planetary carrier calculations, for example. It does an automized meshing and a solving of the mesh, and then the result are either given in a FEM viewer if you would like so, but the main results they are given in the report. So, and we can find in the report, we can find the results as per the FEM calculation, but for comparison we also see the stresses, tooth root stresses as specified in the standard. So in this case we can see that with our current grinding notch which we have here, the stress at the 30 degrees tangent, which is defined by the standard, is now giving different results than the stress at the as the greatest stress. And so we can see in this case it's good to have an calculation which is more advanced than the standard. However, the standard is not too bad neither. It means also KISSsoft uses automatically the values, the geometry values, to consider the effect of the grinding notch as well. So also please check these results as they are still the valid or the to be used values for the strength calculation. However, with this new module you will have the possibility to check in more details as so far in more detail the changes by the grinding notch. So the next module what I would like to show you, also a new feature, is also related to manufacturing, but it's not considering grinding notch, it's considering profile modification. It may be the situation that the engineer does a tip relief for the designed gear, and the tip relief for the designed gear typically is done by the comfortable button in KISSsoft, the sizing button. So, and the sizing, let's say for a short profile modification, happens very easily. These values are calculated and are overtaken into the modifications tab, and they will be considered then in the contact analysis. Now, as you will go to manufacture this gear, the engineer for manufacturing will find that he has several grinding worms maybe, and the grinding worms are created, in this case they are created by profile dressing wheels. It means the profile dressing wheel has a final shape, has a constant shape, and also then the grinding worms, they have a final shape, and the engineer is wants to check the tools and wants to find out which of his tools, currently there are 3, which of his tools will give a very similar tip relief as the one which from the design is the most favorable one. So with these 3 tools you may see that the first one does not create any tip relief at all as it is out of the gear. Then the second one gives a 44 microns, and the last one gives a 265 microns, which is is really very much. So in this case, the 44 matches very well with the 41, and in this case, the manufacturing engineer may say, okay, I would like to take that one, and now in this step, the tip relief from the design, they are replaced by the tip relief generated from the grinding worm and dressing wheel. So this module will give you a big chance to check your current tools and whether you can apply, or maybe you need to purchase a new tool which fits better to the needs of the tip relief. Also in the new release 2017, we made some more details for the gear body. Deflection means if there is a gear body deformation to be considered, now we modified this module, which we already have actually in the 2016 release, but we modified so that it generates a stiffness matrix. This also means vice versa. The stiffness matrix is not necessarily to be created by KISSsoft. It may be created just by any FE tool which you have in-house, and still KISSsoft gives you the chance to create the stiffness matrix of an maybe asymmetric gear body, and to use this then for the phase load factor calculation. So we still think it's a good tool to have for the design engineer. He does not necessarily need to go to the FEM department to ask for a stiffness matrix. He can do it right on site during his job to do the design of the gear body and to see the influence then of the phase load distribution KH beta. So we will continue to see more news in the new release 2017. I will move now to plastic gears. In plastic gears we have one main module which is very new, and actually the purpose is to generate the plastic material data. It is a known problem that for plastic gear calculation the material data are needed, and to create this material data, it's not an easy calculation, and now with this module we want to simplify it as much as possible. So you can see here there are several tests are done with test gears. You can see they are varying in torque and they are varying in temperature. So starting here with temperature, but they are all failing in route. So out of these data, then the plastic material data, they are generated. So, and also then the engineer will decide, we can see it nicely in the graphics, the engineer can decide how the material properties should be, for example, in the endurance lifetime. It means there are some options, maybe to set cycles to infinity, or to have an extrapolation with an average slope, or even to have an extrapolation with average slope divided by 2. So you can see you can directly influence the material properties, and you can also then directly create the necessary dot files which are used from KISSsoft and write them into the material database. So this is a module which is for sure a big help for companies who do plastic gears and who needs to make sure that the material and the product which they finally sell, so that these materials they are correct. Okay. I will continue now with some more plastic materials. I hope you can hear me well. We're sorry for the inconvenience. There are also in the new release, there are some more features for plastic here calculations. And you can find in module specific settings that now properties can be defined which depend on material combination. It's a known fact that, for example, in this case it's POM and PA. If these gears they are running in combination, then the coefficients for wear is different than with other combinations. So if we just check now the current state, we can see now a safety against wear. Yeah, these values still belong to the previous setting, which does not use the material combined properties. And now if I recalculate, this setting will be active, and now you can find that the safety against wear does change dramatically. Means the first gear has much lower safety and the second gear has a much higher safety against wear. So this is definitely an option which is very close to the practical observations which are done. Now I would like to change to the bevel gears. In bevel gears we added the functionality for modification sizing. In this case, the design for the bevel gear was done, but the engineer wants to apply modifications. And as a typical start for modifications as lengthwise crowning, a value from literature is taken. In that case, it was following to the literature, which says that the face width defined by 500 is also then the crowning which is to be applied. But the engineer would like to check more detail, and he runs a contact analysis. In the contact analysis, he will find that the contact pattern on tooth flank looks quite okay. It means it's a robust design, and also it's important, this is the contact pattern which appears with the V, H and J values, which are the misalignments under load. So, but still the engineer would like to check which is the best lengthwise crowning, and therefore the modification sizing helps to find out. It means the profile crowning is applied in the values which are given in the modification tab, but in conditions 2, the engineer now wants to check the values between 20 and 100 microns. This is done now with 5 steps, and it does now all the calculations having crowning between 20 and 100 microns. The final target is not even to find a more noise optimized design. KISSsoft is a tool for sizing and for design, but not for manufacturing. So for manufacturing you will need definitely a tool which is from example from Cage, which will do then the final optimization in noise, but the engineer will see at the moment already about the different results, and he will find in the graphic that so we have the horizontal axis as transmission error, and we have the vertical axis as the maximum tooth root stress. So, and as a third axis we have the design parameter, the lengthwise crowning, and we can find that this value is this solution number 2 gives the lowest tooth root stress, but also an acceptable noise. So, and this solution may be overtaken now into the tab modifications. It's not only the noise excitation, it's also about temperature, it's also about scuffing. Also these parameters, they are to be checked during the design, and here we can already see the result. Also the contact pattern looks still acceptable. So this modification sizing is added to the release 2017 now also for bevel gears. We move on now to the shafts calculation. Also for shafts calculation we have some new features which we would like to show you now. One of these is the rough sizing of shafts. This may be an existing design or a new design which you currently want to do, and you can see that with this sizing functionality you have many possibilities as changing the shaft design and changing roller bearing design. For this sample I will use both of them, and now I get from KISSsoft I get a sample, and we can see the red line was the previous design. So, and it means the new design is now with the bigger shaft diameters here, but smaller here, and also the bearings, they are already adjusted also to the required lifetime. So in this case KISSsoft gives a new proposal for a shaft and bearing design. A second point which is in the shaft design is calculation with forced response by unbalance. So far it was already possible to rate the shafts according to the eigenmode. But in the new release there is now the possibility to check about the eccentrical masses and the forced vibration due to unbalance. Here we find that, for example, this gear is assembled with a very small eccentricity of 1 millimeter and with 10 grams of mass, which is working in unbalance. And now we can check the effect of this unbalance. We can check in the forced response, and currently, as we can see of the previous calculations, we can see that a critical speed in that shaft, this may be now very high values for a real shaft, but in that case we will find that between 50 and 80,000 RPMs the unbalance and gets to a resonance. And of course for these calculations we also need damping values. And now we can check about the shaft force vibrations. We can find a peak really in this area where it was assumed by the critical speeds calculation by the eigenmodes. And we can also check about the bearings. As there was a documentation point was defined for bearings, we can, for example, check for the bearing about the additional torque and the additional force created by this dynamic load. So this also gives then a tool for the engineer to check about the effect. You can see here this is a cylindrical roller bearing which is sensitive for moments, for bending moments. And so when the engineer knows that he has sensitive designs, he will need to check also forced responses due to unbalance. So this was for the shaft calculations. I will now show you some new features also in the bearing calculation. In the bearing calculation, one new feature is a fine sizing. Now we are in the module of roller bearing calculation. As a standalone module, it means here the load, the operating load data, they are given by the user. But in some cases it may happen that the engineer can decide about the inner geometry by himself, and therefore the new functionality is now given in the release 2017 to use a fine sizing. Fine sizing in KISSsoft typically means it's a variation of parameters. You can see the inner, outer and external diameter, they are fixed, and then some other, they are varied. I will start the calculation. And also then the results, they will be given as a table and in a graph. Typically the graphics, they are quite nice to see a fast overview for the properties of these new bearings. We have on the horizontal axis, we have a radial stiffness, which is important for bearings, and on the vertical axis we have the lifetime, and as a color scale, once again, we have a design parameter. Let's say we have the number of rolling elements. So, and we can find that the number of rolling elements, of course, they will be smaller in diameter to match in the same space. The higher the number of the rolling elements, the higher is the stiffness and the higher is the lifetime. So these are news from the bearing calculation. One more news I would like to show you as a last one from KISSsoft side, and it's the calculation of elastic rings. Elastic rings of roller bearings may happen, for example, for planetary planet bearings. It means the outer ring of the bearing is actually loaded by the two gear contacts you can see here. So it's in opposite direction of each other. It's a gear contact actually acting on the bearing outer ring. You can see these are the definitions which we can easily import from a planetary gear calculation. And now, as these forces are acting on the outer ring of the roller bearing, the outer ring will slightly deform. I will change to the properties from the internal to the external ring. Now we can see that the outer ring is now considered as deformed, and with the same it will also change actually in backlash, it will change lifetime of the bearing. So this is a very this may be an important calculation if you do planet gear designs, as there is always to be considered a balance between the maximum size of a rolling bearing and of course to have a stiff design of the gear body. So with this new tool you are able now to check the deformation um, of the roller bearing under the load, for example in a planet gear. So with these features, actually I will close the part from KISSsoft and I will move on now to my colleague. He will continue with KISSsys.
Yes. Hello also from my side. As Mr. Langhart told before, I would like to show you now the release highlights in 2017 version from KISSsys side. There are some new features in the handling of KISSsys and as well some interesting ones regarding the system calculations. And I would like to start here with the modeling part where we have an update there, especially for complex kinematics, for complex planetary stages. We have now predefined stages already in the software. So I just start KISSsys and the administrator, and then here you have the group box first in English. Yeah, we have the group box where we have the group templates new with the predefined planetary stages additionally. So this window is and all the colors are new for this release. And how to build the model now, how to build the kinematics now out of these predefined stages. Just for an example, I just add a basic planetary stage with some planet ring mesh, and additionally I add here a Wolfram set. So you see both groups here in 3D, and I would like to combine them now also. So it's not just having a predefined stage, it's also about combining these stages. And to combine, I would like to have at the end of the first stage, so at the carrier shaft here, I would like to have that the sun shaft is merged with the carrier shaft here and that it's continuing from there. Means I go here to the carrier shaft, go to the option merge, and I select with which shaft I would like to merge this shaft, and here it will be sun shaft of the second group. And in the positive Y direction means here the Y axis is the blue axis, which you can see, and positive will be on this side and not on this side. Just click on OK, and then we will find back the stage there. Just by making a refresh, also the planets will be positioned, and we have our two-stage planetary gearbox already, where we have already also a Wolfram stage for the second one. So in this way you can combine all different predefined stages, and the procedure would be the same now to add the couplings and defining the kinematics, calculating the operating conditions first, and then calculating the strengths in the system. So there is a big update for complex models which can be used. So this is first part for the handling. Then second one, rename and delete of elements actually. So let me open one of the example models. Just file open. Open a two-stage helical gearbox just to show you this functionality. So if you check the model tree of this model, I would like to rename now. So it's a finished model, two-stage gearbox, and I would like to rename the name of this gear. First, I have to go to extras and settings. And here by default, normally this flag standard processing functions in the model tree is checked in, means it's not checking the references of the elements. When you would delete now an element, it would just give you error messages without updating the model tree. So you have to go here first and uncheck this to enable this update of the reference in the system, and then click on OK. Now let's say this gear 4, it has already a reference here through this mesh, through this constraint gear 3-4. If I check it with a dialog, I see this constraint is looking to gear 4 on shaft 3. So I go to gear 4 and rename it, just maybe not gear, just G4, for example. And then it's taking a bit more time when it's updating. So normally in the previous versions we would get messages here, and now you see we get just an additional table with the information about where this gear 4 was found before and how it's changed with the new name. And here you can see in which element in the whole model it would have to be replaced. Let's say. So that's a nice feature. You can now, from now on, rename also the elements in the model tree without any messages. So this can be closed. Next is next and renaming. You would like to delete some elements. So if I delete, for example, this gear, right mouse click, delete. To delete an element, it's a bit more difficult for the software because the software cannot know what should happen with the references, but we can help to the customer, to the user, just by giving a message. So we found some references. If you delete this element, you will get error messages. Say, okay, I still want to delete. I got this message, but if I go further, the system is showing me where I have to check which references. So in this element I have to check the following references because this gear doesn't exist anymore, and I know exactly where to replace something or where to change some references. So these are quite interesting changes, quite important changes, especially for when you build the model and you would like to change later on some names. Okay, next point in handling is about gearboxes with power split. So let me open one of the prepared power split model. Okay, and if you check this model, it's a standard case where you have a power input and the power is going through two branches and then coming together to one gear, one mesh. And if you would calculate basically this kinematic in KISSsoft without doing any changes, you will get a kinematic calculation error. And until now, you had to modify this kinematic function by creating a function in the system and giving some or creating some additional lines of code. Now we improved this point as well for release 2017. You can go here now just to System, make a right mouse click and go to Define Power Split, and it's showing you now just one path or one mesh, and you have to define the percentage which goes, the percentage of the power which goes through this mesh. Let's say 0.55 there, 55%, and 45 will be the other side, and then kinematics will be calculated automatically. If you make a refresh, you will also update then the 2D. So you see it's also a big improvement. It was taking too long to create this, to modify this kinematic function and create these additional functions with the lines of code. Yeah. So this would also work with herringbone models where you split the gear in two different gears, and then it has a mesh with one gear and then again with two gears. So these kind of splits will also work with this using this method. Yeah. Okay, now we go further with some system calculations. First point will be the load spectrum calculation with the load spectrum template in KISSsys. Some important improvements there. So if I open one of my prepared model again, okay. So I have again my two-stage gearbox, and I prepared already the efficiency template here. Just add it because I would like to consider this the efficiency calculation together with the load spectrum calculation, and not just efficiency, maybe also doing the heat transfer calculation. So I also already defined some parameters for the housing and so on. So first I would like to add the load spectrum template in the 17 version. Close that, and I go to definition dialog. Now this dialog didn't change so much, but one important or one couple of new things here is that you can define now K gamma for every load bin, the alternating bending factor for every load bin, and also this is something which is also implemented from KISSsoft side, that we are able to consider the temperatures for every load bin. So you can enter different temperatures and they will be considered also in KISSsoft side. Let's define a basic load spectrum calculation with 3 bins, and in hours, the duration in hours, and the speed and torque defined at the input boundary here, and we don't use any additional columns here. So let's say I have 1000 hours first bin, 3000 hours, and maybe 4000 hours last bin. And for the nominal load, if I check the nominal load, I have 10 Newton meters and 2000 RPM there at the input shaft. So I can increase the load here from 20 first bin, then maybe 25 to get somehow maybe some damage, then to 30, and the speed, let's keep 2000 RPM, 2300 and 3000. Okay. So next point after the definition, we would like to calculate with this spectrum. We go to the bottom, run calculation with load spectrum from template, and here we have some nice new functionalities. This was already the same. We calculating with full load spectrum, single load or reference load. Then what is the new points are here. So we can consider the power loss from efficiency template. So we can run for every load bin the efficiency calculation using the efficiency template in the background, and we can give out the losses and the dissipations for every load bin. So you can calculate a whole map using these methods. We can execute model analysis using all load bins and execute as well contact analysis to get the peak-to-peak transmission error for every load bin, for example. I would like to show you the consideration of the efficiency. Yes, housing stiffness is also something I have to mention here, that we can calculate for every load bin the translation and the tilting of the bearing outer rings, considering the housing stiffness for every load bin and also with the total load then finally. So let's do this demonstration with considering the power loss from efficiency template and click on OK here. So now what it's doing is running first bin and then the efficiency calculation. I have to define the temperature again for the oil, for the lubricant in my system. I have oil bath lubrication just for the information here. Then running efficiency again, running bin 2, and bin 3 finally, and doing the main calculation. So the general report is created. This is the general KISSsoft report for the strength. Then if I go to the folder, it's creating a new folder here with a two-stage helical gearbox. And if we open that one, you will find back the results CSV where we have all the safeties for every bin for the gear pair calculations and the lifetime for every bearing for every bin. And if you have some cross sections, you would also get the static and dynamic safeties for the shaft. The same goes for the damages, so just the damages for every gear, the damages for every bearing, for every load bin. But what is new is that if you calculate the efficiency template in the background together, then we create this additional result file, efficiency template CSV file, and there you can get, in this case, all losses and all the dissipation through the different parts for every load bin. So like this, you can really create a map, or you can do an offline evaluation of the data. So this is one very nice feature actually, and the other one is now we generate the results of some variables, of predefined variables from our side, but it can be that you would like to have user-defined export from different variables which are existing in KISSsys. And for this, it's possible to go to load spectrum template and define additional data for the export. And let's say we would like to give out the KH beta for every gear, for every load bin. And that's why I go to the KISSsoft helical gear pair. I would like to see the variables from the KISSsoft helical gear pair calculation in KISSsys. Efficiency, I don't want to modify, that's already okay if it's here. So helical gear pair, and the system KISSsys is showing me all variables which are related to helical gear pair, and here I would like to change the value in front of KH beta from 0 to 1, which means that KISSsys will generate a CSV file which is called general CSV, where I can check the results for these variables for every load bin. So KH beta, and let's say we would like to have also maybe the torque for the gears for every load bin just to double check if KISSsoft is calculating with the correct values. So that's it, and then we can close that. Yes, and then that's the second one because we have an efficiency template, and it would like to ask me about if I would like to modify. I don't want to modify the variables for the efficiency calculation, and then we can go again to the calculation of load spectrum. Now I'm not interested in efficiency calculation anymore, just want to run the load spectrum calculation and see which values I get for kh beta and for the torque, which I defined. And this it doesn't take so long like before because I don't run the efficiency calculation in the background. And once the calculation is finished, I can check my model, my folder from model, and here we generate the general CSV file again with the mentioned data for kh beta for gear 1, gear 2 calc and gear 3, gear 4 calc. And then as well the different torques on the different gears. So T1 is always torque on gear 1 and T2 always torque on gear 2, and in front you can see always the explicit mesh which is used here. So that's like this. You can really export in a very more easy and automatized way your parameters, and you can make again the offline evaluation of the data. So I go back to cases. That's it actually for the load spectrum calculation. So we have some additional new small improvements, and you can always check the handout in the attachment of the web demo to see the more detailed features as well. So now I come to another system calculation, the system reliability, and here I would like to open this model again, and just some couple of words to system reliability. It's something new which we implemented in KISSsoft just in 17. It's to combine the different material failure probabilities which you can have in a system coming from the different standards. Like for the shafts, there is most is used 1%, for the gears 1% material failure probability, and for the bearings default 10%, which can be also changed in our software. And we use this to compare all these elements in a system. So what we have to do in KISSsys is I would like to change the total, because it depends on the total required lifetime as well. So I add settings table here into this model and change the system required service life from 2000 to 10,000, and I connect it. And I run here with this new icon here next to the housing stiffness calculation and calculate the reliability. Here required service life 10,000 hours already taken from my setting, and we can run just the reliability or tooting, the reliability for the different elements as well, bearing, shafts, bearing and tootings. And we can change the diagram from linear, log, linear, depends on the number of amount of hours which you want to display actually. So let's do the reliability calculation, and just want to explain the system reliability here. We have up to 60,000 hours goes down, the reliability goes down for some elements to 18%, and the rest is almost in the if we check now for 10,000, we are almost at between 80 and 99,000. So on the right hand side we can be seen which element refers to which color, and then there can be done a detailed analysis in the system. We have also these graphs for every different element, so for bearings, for gears, and separately, and also the tables. So we have here, for example, it's a very nice result for 10,000 hours, which was required from our side. We have 87.461% reliability. If this reliability is too less for us, if we would like to have high reliability, then we will not reach these 10,000 hours. We have to say, yeah, okay, we will reach 99%, these 5,086 hours, or this 4,152 hours, depending on how reliable our system should be. Yeah. So that's for this system calculation. And next point is the auxiliary results table, also one of the system results. If we add from the default templates the auxiliary result template, which is named as aux results by default, and we have a new new design here and some additional features, like we can calculate we added the cost calculation here of every element and of the whole system, and we added the torsion. We can calculate the torsion of the system, torsion of the gears, torsion of the shafts, and from that here we give out the degree, the torsion in degrees, and from that we can calculate the torsional stiffness of the different elements or of the system. So coming to the price, there are some price settings which can be done here, defining the bearing prices per kilogram and the costs of shafts per kilogram, of pinion shafts where the gear is already considered, or where the pinion gear is already considered, the gear cost of gear per kilogram, and the bearing per kilogram as well. There can be also a list set it behind to consider for the bearing prices, to be considered for the bearing prices. Okay, and then there is one button to calculate all of them, or we can just calculate the interesting part for us. The results can be seen in the tables for gears, bearings, shafts, and for the system finally. Okay, then next point it will be the export of the system. So sometimes, okay, you did your analysis, you did your calculation, you built your you have a final model, and you would like to use these for further analysis in different tools, maybe to do some detailed dynamic analysis. Maybe for this we provide now a XML export of the whole model, which can be done by using this shaft system analysis icon, just adding to the model and going there with a right mouse click and using export system model data functionality. And I will export these to the desktop. And I would like to check that as a text file. You can see how structured it is, but if I rename this as XML, I can also open it with one of the explorers. and see the structure. Okay, like this. So here it can be really nicely adapted. So you have first part, you have the units. Then we have the different shaft calculations, like how the model is built in KISSes. So in every shaft calculation, we can find back the shaft itself with the different origin and with the coordinate system, with the x-axis, y-axis, and z-axis vectors, or the orientation in 3D, and then all properties and geometry details of every shaft. Then we start to show the bearings which are on top of the shaft with the name, orientation, and the bearing geometry, inner geometry, and bearing stiffness matrix. Then it's starting the second bearing, and then we have a gear on the shaft, and we give the same orientation, the geometrical values, and some reference profile values for sure, and also modifications. If you have applied some modifications in KISSsoft side, we also show them here in this export file. And in this way, we start the second shaft calculation, exporting, and so on. And we have also information about the connectivity of the different elements. So the constraints somehow also as information here. Yeah. So that's it actually from KISS's side in general. Yeah. Yeah. Thank you very much for attending to the web demo. If you have additional questions, you can write an email to info@kisssoft.ag. And if you're interested to test all these new features from KISSsoft and KISS's side, you can ask for a test version as well. And yeah, we wish all of you a nice day or evening, depending where you are, and hope to meet you next time. Bye.